Okay. All right. So let's take a look at this one. So he bought this computer for 1200 from store A, and then at store B, the same computer was advertised for 1180 at an additional 10% in-store discount. So A is the price of the computer at store B. So basically, if we start with 1180 and we want a 10% discount, well, we want to think of it as we start with 100% and we're taking 10% off. So we're going to multiply it by like zero point 0.9 or point, you want to think about it as 0.90 because we're keeping 90% of the price. And that's going to equal A. So if we just do that, so we get A is 1062. And then it says, um, what percent of 1200 is A? So typically when you do these, if you have trouble, you can always think of it as you do is over of. So A is 1062 of 1200. And then if you just divide them, that's 0.885. And they actually want that in percentage form. So that's just 88.5%. Okay. All right. Let's try the next one. Okay. So basically, after this 40% discount and sales tax, the price was this, and they want the original price. So let's just say the original price was X. Whoops. So again, what we want to get into the habit of is to take these percent increase and percent decreases and be able to just represent them with a single number. So a 40% discount, like the last problem, we had 10% off. When you have 40% off, that's going to be keeping 60% of it. So if I multiply this by zero point 0.6, or think of it as 0.60, so that is keeping 60% of it, which is the price you would pay after a 40% discount. And then we're going to multiply that by a number that's going to represent a 6% sales tax. So a 6% sales tax is a 6% increase in the price, which means if we start at 100% and add 6%, we're at 106%. So we would multiply by 1.06. So if we multiply by 0.6, that's the 40% discount, and 1.06 is the 6% sales tax. And in the end, it equals $15.90. So you could do this a bunch of different ways, but I would just in the calculator, if you just do the 1590 and divide by 0.6, and then take that answer and divide by 1.06, you get X is 25. So the original price of the shirt must have been $25. Okay. All right. Try number three. It says Nina bought a pair of shoes for 43.20, and that included an 8% sales tax. So when she returned it, she was refunded this, which included the full refund of the 8% sales tax. So the return price was what percent of the original price, like excluding or not including any sales tax. Um, so what we have to do is figure out like what the sales tax was. So she bought a pair of shoes, which included this. So basically, whatever the original price was, if we multiply by 1.08, that's again how we do an 8% sales tax. So that should equal 43.20. So we simply find the original price just by doing 43.20 divided by 1.08. So that's $40. So the original price of the shoes was $40, but it's important to note that the tax itself was $3.20. Um, So then when she returned the shoes, she was refunded $36, which included the full refund of this tax. So the important thing is we can't do 8% of that because it's 8% of a different number. So now 36 minus 320 is 32.80. All right. So the the actual price that she was refunded was 32.80 and the original price was 40. So then the final question is the return price is what percent of the original price. So this is again this like is over of. So 32.80 is what percent of 40. You just divide those and it gives you 0.82. So the original price must have been 82% of, or sorry, the refunded price must have been 82% of the original price. All right, let's move on to number 4. Okay. All right. So this one we got to kind of stay a little bit organized because we have a couple different things going on here. We have like the population of bird A. Whoops, keep doing that. We have like the population of bird A and bird B. And then we have in 2016 and 2019. All right. So we want to like keep track of all those. Um, So the key is the population of bird A in 2016 was 6,000. All right. So we have that. And then we also know that bird A in 2019, they were the same. So what we want to do is basically figure out what A was in 2019, which means that's what B was, and then work backward to figure out what B is in 2016. So in 2019, or so from 2016 to 2019, A increased by 5%. So we start with the 6,000, and to increase something by 5%, we multiply by 1.05. So let's do that. That gives us 6,300, which again means bird B was 6,300 because A and B were the same in 2019. And bird B increased by 20%, but we don't know what 2016 was. So here we're working backwards. So what we got to do is kind of think of, well, in 2016 it was X, and then it was increased by 20%, which is multiplying by 1.2, or think about it as 1.20 to really like see the 20. That is going to equal the 6,300 that it ended up being in 2019. So then all we do is divide. So 6,300 divided by 1.2, and you get 5,250. So that must have been the population. So you can't like take 20% of 6,300. It's 20% of a different number. So you got to look at it as increasing by 20% is the number 1.2, and then you just kind of divide to figure out what it was originally. Okay. All right, now we move on. The next set of problems have to do with like unit conversions. Okay, so the way that I like to do all of these like conversion factor problems is to use what's called dimensional analysis. So we're just going to start with the 3 times 10 to the 8th, and this is meters per second. All right, so each time, what I'm going to do is I'm going to multiply by what's called a conversion factor. And that conversion factor is, for example, 1 kilometer is 0.62 miles and 1,000 meters is 1 kilometer. So I'm going to use the second one first. 1,000 meters is 1 kilometer. So that really leads to 2 different conversion factors. One of them is that there's 1,000 meters in 1 kilometer, or the other is that there's 1 kilometer in 1,000 meters. But what I want to do is I want to choose this one, the 1 kilometer in the numerator and 1,000 meters in the denominator. And the reason is because I want the units, the meters unit to cancel. All right, so I want to get rid of this and I want to get rid of this. So every time I choose a conversion factor, it's going to be so that the one before cancels. And then finally, I should be left with miles per minute. So now I'm going to change kilometers into miles. So 1 kilometer, which I'm going to put on the bottom again so it cancels with this, is 0.62 miles. So this cancels. Now I have miles, so that's good. But if I were to stop the problem now, I'd have miles per second. But I want miles per minute. So this one they don't give us, but we should all know that there are 60 seconds in a minute. So I'm going to put the 60 seconds on top and the 1 minute on the bottom so that this seconds cancels with this seconds. So again, when I look at the units that remain, I have miles in the top and minutes on the bottom. So that means my final answer would just be miles per minute. And then you can just use a calculator for the rest. So you're going to do 3 times 10, whoops, to the eighth, multiply that by 0.62, multiply that by 60. Whoops. And then take that answer and divide by the 1,000 on the bottom, because the rest on the bottom are just a bunch of ones. So I divide by 1,000.
All right.
I get answer choice. It should be A. I was just double check because the way my calculator gave it to me, it was like this. So it's one of the 1.12 ones, and then I have to move the decimal over 1, 2, 3, 4, 5, 6, 7. So then it's A. Um, I want to do that a different way because that you shouldn't be taking time turning things into scientific notation. So another way to do it would be to just like um, do the 3 times the 0.62 times the 60. That's 111.6 times um, this 10 to the eighth. This is really 10 to the third. So you just get 10 to the fifth. And then basically you move the decimal over twice, which would move this the other way twice, is where we would also get A. So I don't know. In the end, you got to do some sort of moving around. Um, Maybe there was a way to just throw this into Desmos and it would do it automatically for scientific notation. But either way, the answer is A. And the key takeaway to this is the whole idea of dimensional analysis. So let's try number 6. So another one with um, like dimensional analysis. Okay. So this one we're going to start with, again, all you do is you just start with what they give you. So 80 kilometers per hour. And then we're going to, let's say we deal with the kilometers first. Well, 1 kilometer is 1,000 meters. And again, I'm going to put the kilometer on the bottom so that the kilometers cancel. All right. And if I stop the problem now, I'd have meters per hour, but I want to change hours into seconds. You could do this with 2 conversion factors, but I would just know that 1 hour. So again, I'm putting hours on the top so that it cancels with this is 3,600 seconds. Or you could do 2 conversion factors where you have 1 hour, 60 minutes, and then there's 60 seconds in 1 minute. Um, but you could just know that there are 3,600 seconds in 1 hour. It saves you a conversion factor. So now if I stop the problem, I have meters per second, and then I just actually have to do the math. So it's just 80 times 1,000, and then you're dividing that by 3,600. And that is, you get a 22.2 repeating, but it just says which is the closest. So it's clearly A. All right, so a few more of these. This one, you got to be a little careful with the whole square. So try that one. What we start with is the fact that it's increasing at a rate of 4 acres per year. Now it turns out that the year doesn't matter because it ends up they want it square kilometers per year, but I'm still going to just write it. So I just look for the rate they give us. So that's here. And then we're going to work to change it to square kilometers per year. All right. So the first thing is there are 640 acres, which again, I'm putting acres on the bottom because acres are on top here, in 1 square mile. So we write it like this. We say square mile, but we write it like 1 mile squared. And then we have to change square miles into square kilometers. So typically the mistake here is to just use this like as it is and put miles on the bottom. But the thing is, we need to cancel out square miles, not just miles. So what you do is when you need to do that, and this works for if they're using cubic as well for like volumes, you just square the whole conversion factor. So it works like this. Well, like an equation, you just square everything on each side. So 1 squared is 1 kilometers squared, right? That's really square kilometers, but we write it as kilometers squared. Then I got to do 0.62. So 0.62 squared is 0.3844, and then I'm squaring miles. So what happens is 1 kilometer is 0.62 miles, but a square kilometer is really 0.3844 square miles. And again, I'm getting this 0.3844 from squaring 0.62. So the conversion factor that I need to use is this 0.3844 square miles is equal to 1 square kilometer. Then I get the correct cancellation. Now I just do the math. So I just do 4 divided by 640 and then take that and divide by 0.3844 and you get like 0.0163, which is answer choice D. And you can be certain that if you just put 0.62 on the bottom here, that answer would be there. I think it would have been answer choice C. So you got to be careful when they change when the conversion factor is either square units or cubic units. You have to do that to the conversion factor to make sure that all the cancellations actually work out. Okay, let's do one more like that, very similar. And then we'll move on to the last topic of the night. Okay. All right. So this one we just start with 11,863,808. Again, it's square yards. So what we need to do, and I'll show you another way to just write this. Like on the last problem, I really didn't need to, I could have used the calculator a little bit more to help me. Is we want again, we want square yards on the bottom, which means we need to square all of this. So that means 1 square mile is really 1,760 square yards. So again, we could figure this out, but now I would just use the calculator. So I would just do the 11,863,808 and just divide by 1,760 squared and you get 3.83, and then that's in square miles. So the answer should be B. So again, the key is not to just divide by the 1760. You have to square that. And like I said, there's problems where they're talking about cubic units. You'd have to cube everything. But though in conversion factors, you're always going to have the number 1 in it. So the 1 will get cubed as well and it'll stay the same. But the other number, cubed or squared, is important that you do that. Okay, so then the last kind of topic we're going to go through is in same like domain, but we're just like ratios and proportions. So again, try this one. Okay, so this one, I'm going to look at it like this. So if my ratio of pistachios to walnuts is 5 to 6, and then I have a ratio of walnuts to cashews is 4 to 15. The only way to get a relationship between pistachios and cashews is if the walnuts are the same. And we want to just think ratios are just like fractions. So what I want to do is kind of like find a common denominator in a way. So 6 and 4 both go into 12. So I want both of these to have 12 in them, which means this one is being multiplied by 2. So this becomes 10. This is being multiplied by 3. So this becomes 45. So that means if I do pistachios to cashews, I'm at 10 to 45 because now I can like cut this one out because it's the same. So then it wants the ratio to be 2 to something. So now I'm just reducing it. So therefore I'm dividing by 5. So if I divide this by 5, I get 9. So like the answer to the problem, like the value of k must be 9. So you're just really attacking it's just fractions, just common denominators and such. All right, let's try a couple more. So number 10. Okay. So here is an example of it. We didn't apply to the problem before, but if I'm given like one proportion like this or one ratio, um, one option in these problems is just like attach x's to them, meaning like this means if they're in ratio of 7 to 4, and let's say we're dealing with like whole numbers only, then it's going to be like some multiple of 7 and 4, but it's going to be like the same multiple. So it's like one of them is 7x and one of them is 4x. And not that we need a visual for this, but if you want one, basically the ratio of the length of the width is 7 to 4. So that means we could think of the length as 7x and the width as 4x. All right. So that's what I mean, just like attaching x's to them and then just doing whatever you have to do in the problem. So if the area is 252, then the area is length times width. So 7x times 4x is 28x squared. That's equal to 252. And then it's really simple to solve. So you do 252 divided by 28, and you're going to get x squared equals 9, which then means x is 3. And then they want the width. Well, the width is the 4x. So if you plug the 3 back into that, 4 times 3 is 12. All right. So if you have a ratio problem like that and you have to like actually do like math with it, so like in this case geometry, just attach x's to each of them and then just like do that math. All right, just a few more. So take a look at number 11. Okay. So this one we're going to kind of do a little differently than the other ones. We're going to really, really think of this as a fraction. But let's start with Gina's age. So Gina is 3 times her daughter. So we'll call Gina G and her daughter D. And then 5 years from now. So what's going to happen in 5 years is they're both going to age 5 years. So here's where I'm going to turn it into a fraction. I'm going to say, okay, 5 years from now, Gina is going to be G plus 5, and her daughter is going to be D plus 5. And the ratio of their ages is going to be 7 to 3. So now I think it's easier to just think of it as a fraction instead of an actual ratio. But Gina is really 3D. So now I get this 3D plus 5, which is just Gina aging 5 years, and then the daughter aging 5 years. The ratio of their ages is now 7/3. And D represents her daughter's age now. So if we just solve this for D, we will get the answer to the problem. Well, the reason I set it up like this is you could just do cross multiplication. So this is 9D plus 15 is equal to 7D plus 35. And then if I move the 7D over here, I'll get 2D. If I move the 15 over here, I will get 20. So then D equals 10. And again, I like to make sure, I said it earlier, but that the value I'm solving for, the variable, is actually what they're looking for. And D is how old the daughter is now. So the answer to the problem is 10. All right, we are going to do one more problem. So this is basically applying ratios to like a geometry problem. Okay. So when they say when you have triangles that look like this on the SAT, they're going to be similar triangles. But because if they weren't, there really wouldn't be much we could do with it. But to see like why, when they tell us, first of all, similar triangles mean that all three angles are the same. We know these are the same because they're vertical angles. And then if AB is parallel to DC, then if this is the transversal, this angle is the same as this angle and two angles is enough. But then if this is the transversal, that angle is the same as that angle. All right. But we don't need to prove this. The whole point of going through that is if you see the setup with these like two triangles like facing each other this way, they're going to have to be similar. Okay. So that means that if I do 52 over 91, that's going to be the same as doing DE over BE. But that's too many unknowns. And we want the length of BE. So I'm going to call that X so that whenever we finally solve the problem, I don't have to do anything else. Like I know that that is the answer to the problem. So I'll call that X. And if I know the whole thing is 286, then the ED part of it has to be 286 minus X. That's kind of the key to the problem. So now, I chose to do 52 over 91, this one over this one. So then I got to do 286 minus X over X.
All right.
Now I just cross multiply. So 52X. If I cross multiply this way, I got to do 91 times 286 is 2000, 26,026. Whoops, fix that. Minus 91X. Add the 91X over. So 143X is 26,026. And then finally divide. And you get X is 182. So again, that is the length of BE because back when I could have made this one X and this 286 minus X, but you want to when you get to choose the variable, you want to make it the thing that you're solving for just to save you time from having to like plug in again. So the
Okay.
final answer is just 182.
Got it.
Okay. All right. Well, then that's all I had for today. So again, thanks for coming, and I'll send out another email with all this and just
All right.
information about next Monday.
Got it. See you next
Okay.
week.
All right.